Good morning to you all. We finally made it to April. I hope you guys are surviving. We are going to start chapter 6 now. In chapter 5, a lot of what we did was we were multiplying polynomials together. In chapter 6, we talk about doing this in reverse. We are going to be talking about factoring. And something is factored if it is written as a multiplication problem. And so if you were able to plug in a number and then follow PEMDAS, order of operations, the very last thing you would do is multiply. Okay? Some of these are going to have addition in them, they're going to have subtraction in them, but the very last thing we should do is a multiplication. Okay? We're going to be talking in this section about the greatest common factor and then factoring by grouping. What I would like for you to do is in my math lab, under your blank notes, you have a factoring guide. One of them looks like this, okay? And it is obviously handwritten, and this works for both Math 320, which is what you are in, and Math 330, Intermediate Algebra. There are some things that they learn in Math 330 that you do not. So you have this option, or you have this option, okay? This one is specific for Math 320, and it will talk you through it. I'm going to be using this one more, but the other one still works, okay? So I'll try to link to these in the comments. The greatest common factor is the largest value that divides evenly into every term you have. It is the complete opposite of a least common denominator or least common multiple. LCD and LCM are essentially the same thing. Okay? Here's things you need to remember. A GCF, a greatest common factor, will never be larger than your smallest value. Okay, if you glance down here, we're going to find the GCF here. My GCF cannot be bigger than 4 because 4 is my smallest number. Okay, this is one of the weird topics where dealing with variables is actually easier than dealing with numbers. If your terms involve variables, you should write down only the variables that appear in every single term, and then you pick the smallest exponent that variable ever has. This is very easy. You'll see it when we get to an example. Okay, so right now we're not really factoring completely, we're just getting practice finding the GCF. Okay, what we're looking for, if I want to find the GCF of these three numbers, 40, 20, and 4, I am looking for the largest value that divides evenly into every single term you have. Okay, so what I generally do is I start with my smallest value of 4. Does 4 divide evenly into 40? Yes. Does 4 divide evenly into 20? Yes. 4 also divides into 4. You get a 1 when you do it. So 4 is your GCF. Okay? Now for reference, your LCD, if these were all in the denominator, an LCD is the smallest number that everything divides into. Okay? 40 doesn't divide into 4. 40 doesn't divide into 20. 40 divides into 40. Okay? 4 divides into 40. 20 divides into 40. Everything divides into 40, and that's the smallest number that happens. So this would be 40. They are completely the opposite. And it is confusing because this one says greatest, and it's the smaller one, and this says the least, but it's the bigger one. It's just something you've got to keep in your mind. Okay. Now, let's look at this one. 4, 9, and 12. My GCF cannot be larger than 4. All right, does 4 divide into 9? No. 4 does divide into 12, but I need it to go into all of them. So I start thinking of other numbers that divide into 4. Things that divide into 4 are 1, 2, and 4. 3 doesn't divide into 4. We already said 4 didn't work. Does 2 work? 2 also does not divide into 9, so that doesn't work. Your GCF is 1. you always have a GCF of at least 1, and that becomes important in just a bit.